Hi, good day wherever you are, and welcome to my presentation on integrating science and computer science with Lucidchart. My name is Mark Wakita, and I'm the middle school science and computer science teacher at Red Hill Lutheran School in Tustin, California. Teaching is challenging enough without the additional demands of adjusting instruction for online learning. So how can we get more out of our instruction and more out of our students without adding an unmanageable burden on our lesson plan and our learning curve as teachers? In my classroom, cross-curricular instruction allows me to connect science and other subjects to provide students with context and deeper learning. In this presentation, I'll show you how I use Lucidchart to teach science and computer science in a way that not only reinforces instruction, but also gives students a greater depth of understanding. So let's get started and let me share what we've done. While my background is electrical engineering, I think it's incumbent upon us to consider the use of computer science for the additional benefits it provides for the students. Application of computer science to science instruction addresses the top 3 skills cited by the World Economic Forum as skills for the 4th Industrial Revolution. These would be complex problem-solving skills, critical thinking skills, and creativity. Looking at the graphic below, there are 3 additional pedagogical benefits. It supports cross-curricular instruction, it supports differentiation, and it integrates aspects of depth and complexity. In California, the State Board of Education, or SBE, has defined guidelines for our computer science standards. In these, they specify that the standards shall be consistent with, supportive of, and show integration with all other SBE-adopted curriculum standards. Is this reasonable and possible? Yes, it is. I show below 2 sets of standards that our lesson addressed, one for computer science and the other being the NGSS standards. Let me show you how this assignment addresses both of them. This slide shows excerpts from our Pearson Text on science, which integrates the NGSS standards. As you can see, the content is dense and challenging for students to assimilate. Yet our goals for instruction climb the steps of Bloom's taxonomy with the desire for the students to understand, interconnect, explain, apply, and extend this information. Diving into instruction, I created this flowchart for students to help them understand how the process of identifying rocks is done. We know that there are 5 types of rocks identified by the text: extrusive igneous, intrusive igneous, sedimentary, foliated metamorphic, and non-foliated metamorphic. So I pose the question to the students: if you're an expert geologist and you have a rock in your hands, how do you determine which type of rock it is simply by answering yes or no questions on how it was formed? This investigative process forced the students to think deeper on what makes a type of rock a specific rock. Now that the students have walked through the flowcharts with a few example tries, the evil Mr. Wakita now redacts all the components of the flowchart and poses the assignment. Now it's your turn. You have to create this chart. To support students on the assignment, additional ground rules are given. First, you will use Lucidchart to create the flowchart. Our students are one-to-one with iPads, so they have access to the free app. In minutes, they quickly learn the drag and drop, text editing, and arrow connection skills required. You will start and end with ovals. Everything originates from the start, and everything concludes at the end oval. Questions are in diamonds and are only yes or no questions about how the rocks were formed. Once you've narrowed the possibilities to one type of rock, use a box and state that you've classified the rock as some type of rock. I provided this information on the slide. You can add comments along the way to clarify for yourself if you ever come back to the diagram or for a brand new owner. I provided these as well. Next, for those that were up for an additional challenge, or those that finished quickly, I introduced basic programming concepts. The diamond yes or no blocks can be viewed as conditional statements. If some condition is true, the yes case, then do this or do this step. In this case, it's simple enough to turn the question into a statement that can be either true or false. Else, if it is not true, do this or go to this other step. Finally, we conclude this with an end-if statement. You can also put an if, else, and if inside of a statement. I liken the structure to an outline, where each level or Roman numeral, numbers, or letter is connected and taken as a group. Note, all of my students took this option. So with support given only through office hours and some emails, here's an example of what one student produced within 5 days. The student submitted 2 files, the downloaded Lucidchart on the left and the Google Doc on the right. I have them displayed here side by side for convenience. The logic on the flowchart is correct, and the student was able to match the flowchart with the pseudocode example. Having completed this introductory assignment, For the next assignment, I increased the level of difficulty by having the students implement the rock cycle chart of how one type of rock gets converted to another. The algorithm in this example would identify the process if the student could identify the starting rock and the ending rock. Defining the starting rock and ending rock is the student's introduction to variables and variable assignment. This time, with a more complex task, the same student was able to complete the assignment in 2 days. Here's the flowchart and the program. Both correctly implement the algorithm to identify the processes and implement the program. One of the major features of Lucidchart that helped facilitate the process was the ability to chat with the students while sharing their document. Using the sharing and chat, I could see real-time what the students were working on and provide immediate feedback on direction and corrections. Shown here are 2 examples. Note, with my computer setup, I have 2 monitors, so I was able to support 2 students simultaneously. In this mode, I was able to bounce back and forth between flowcharts, helping one student while the other was thinking or implementing. Multiple monitors are not required, however, as the teacher can also open multiple tabs on a single browser. However, this approach can be extended further. This strategy can be applied to other subjects beyond science. Subjects such as language arts, social studies, and math can use flowcharts in programming as well. In talking with our language arts instructor, I created this flowchart for language arts. This example I created could be an example of a language arts assignment. In this case, the student would assess what makes a strong introductory paragraph by evaluating if a hook exists and how strong that hook may be. Thank you for watching. I hope you found something that you can use in your classroom. Best wishes during this time for you, your students, and most importantly, your family. If I can be of any service, please contact me. Thank you.